just ate a banana. The peel is in your hand, and you are about to do what almost everyone does: toss it in the trash without a second thought. But what if that peel, buried just 4 inches underground, could trigger a chain reaction in your soil that scientists are still trying to fully understand? What if I told you that within 9 days, the zone around that single buried banana peel becomes a completely different ecosystem compared to the surrounding soil? The microbial population explodes. Nutrients begin releasing in waves. Nearby plant roots start physically redirecting their growth toward it, as if they somehow know it is there. This is not some internet gardening myth passed around on social media. There is peer-reviewed science backing up what happens underground when you bury a banana peel, and some of it is genuinely surprising. So let us walk through the timeline, day by day, and follow the science of what one piece of so-called garbage does beneath the surface of your garden. First, let us talk about what you are actually burying, because the nutritional profile of a banana peel is more impressive than most people realize. A single banana peel is approximately 80 to 89% water by weight. That moisture alone is valuable because it creates a localized hydration zone in the soil, a pocket of sustained wetness that keeps biological processes running, even when the surrounding ground starts to dry out. But the real story is in the dry matter. On a dry weight basis, banana peels have an approximate NPK ratio of 0.342. That potassium number is staggering. The potassium content ranges from about 30 to 50 milligrams per gram of dry matter, making banana peels one of the most potassium-dense kitchen scraps in existence. Beyond the big three of nitrogen, phosphorus, and potassium, banana peels contain significant calcium, magnesium, phosphorus at around 74.5 milligrams per 100 grams, sodium, iron, manganese, and zinc. They also contain natural plant growth hormones, phenolic compounds, and organic acids that influence soil chemistry in ways researchers are still cataloging. So when you bury a banana peel, you are not disposing of garbage. You are placing a slow-release mineral packet wrapped in a biodegradable casing directly into the root zone of your plants. Now here is where the timeline begins. The moment that peel contacts warm, moist soil, it triggers what soil scientists call the priming effect. The existing soil microbes detect the arrival of fresh carbon, and they go into overdrive. Within the first 24 to 72 hours, soil microbial biomass carbon and microbial biomass nitrogen spike measurably in the zone surrounding the buried peel. Research shows microbial populations can respond to fresh organic matter input within hours, not days. Bacteria are the first responders. They swarm the peel and begin breaking down the simple sugars and starches, the easiest energy sources. Soil enzyme activity increases dramatically, particularly beta-glucosidase, which breaks down cellulose, and urease, which processes nitrogen compounds. The banana peel acts as a microbial buffet. Its high moisture content keeps the decomposition zone humid, and that accelerates both bacterial and fungal colonization. Research by Cial and colleagues in 2019 confirmed this process in detail. They showed that adding banana peel to soil significantly increased ammonium nitrogen, soil microbial biomass carbon, soil microbial biomass nitrogen, and the activity of those key enzymes. The soil around the peel is not just changing, it is waking up. After bacteria do the initial heavy lifting in the first 3 days, a second wave arrives. Fungal decomposers move in and take over the tougher structural work. Fungi produce enzymes that can break down cellulose and lignin fibers in the peel that bacteria simply cannot process. If you were to dig up the burial site around day 4 or 5, you would see visible white mycelium threads, fungal hyphae, beginning to colonize the peel's surface. These hyphae do something remarkable. They extend outward into the surrounding soil, creating a microscopic nutrient transport highway that radiates away from the decomposing peel. This fungal network is critical to the whole process. Saprophytic fungi breaking down the peel can form bridges between the decomposition zone and nearby plant root zones, effectively shuttling newly released minerals directly toward where plants can absorb them. At the same time, the decomposing peel releases organic acids that slightly lower the pH in the immediate area. That localized pH shift makes certain micronutrients like iron, manganese, and zinc more soluble and therefore more available to plant roots. So the peel is not just releasing nutrients, it is actively making the existing nutrients in the soil around it more accessible. Meanwhile, the potassium is doing something different from every other nutrient in the peel. Potassium in banana peels is mostly an ionic or water-soluble form. Unlike nitrogen or phosphorus, which require complex microbial breakdown before plants can absorb them, potassium does not wait. It begins leaching out almost immediately as the peel's cells rupture upon contact with soil moisture. Research by Raha in 2022 studied the release dynamics of potassium from banana peel waste in soil and found that potassium release begins within the first week and continues over a 45-day window, with the most rapid release happening in the first 21 days. This is essentially a slow-release potassium drip, and you have placed it at exactly the right depth. At 4 inches deep, the peel sits right in the active root zone of most vegetables, herbs, and annual flowers. It is shallow enough that oxygen is still present for aerobic decomposition, which is faster and does not produce foul odors, but deep enough that the nutrients release directly where feeder roots operate. A single banana peel contains roughly 422 milligrams of potassium. For context, that is a meaningful dose for a single plant. Commercial potassium fertilizer applications for a tomato plant are in a similar per-plant range. That potassium is critical for flower and fruit production, disease resistance, water regulation within plant cells, enzyme activation, and overall plant vigor. You are delivering a targeted potassium treatment to one plant, for free, from something you are about to throw away. This is where the process becomes genuinely fascinating. Plant roots do not grow randomly. They exhibit what scientists call chemotropism, meaning they grow directionally toward nutrient-rich zones. As the banana peel releases potassium, phosphorus, calcium, and organic compounds into the surrounding soil, it creates a nutrient gradient, a concentration map that roots can sense. Nearby plant roots detect this gradient and preferentially redirect their growth toward the decomposing peel. By day 9, if you carefully excavated the burial site, you would likely see fine feeder roots beginning to converge on the decomposition zone, especially in warm soil above 65 degrees Fahrenheit with adequate moisture. The partially decomposed organic matter also improves soil structure in the immediate area, creating better water retention, better aeration, and more pore space, all of which further encourages root colonization. Research on banana peel compost by Potassium in 2022 confirmed that banana peel amendments significantly increased available phosphorus and potassium in soil, leading to measurable increases in plant growth performance. The roots are not just finding the peel by accident, they are hunting for it. And the peel is attracting more than just roots. Buried organic matter at 4 inches is prime earthworm territory. Earthworms are powerfully drawn to decomposing organic material, and banana peels seem to be particularly attractive to them. Huang and colleagues in 2016 found that banana peels were an excellent substrate for earthworm activity. In their study, the highest cocoon production of 2.6 milligrams per day per worm was observed in banana peel treatments, and worm populations actually increased during the decomposition period. Earthworms accelerate everything. They fragment the peel mechanically, mix it with soil particles, and their castings, what they leave behind, are 5 to 10 times richer in plant-available nutrients than the surrounding soil. So the buried peel creates a self-reinforcing cycle. The peel attracts microbes. Microbes attract earthworms. Earthworms process the material faster and create even richer soil. That richer soil attracts more roots. Each element amplifies the others. The genuinely remarkable thing is that a single piece of kitchen waste, buried a hand's width underground, initiates a cascade that improves soil biology, soil chemistry, and soil structure simultaneously, all in under 2 weeks. Most synthetic fertilizers do exactly one thing. They add a specific nutrient. A buried banana peel does at least 6 things at once. It adds potassium, phosphorus, calcium, magnesium, and trace minerals. It feeds and multiplies beneficial soil microbes. It attracts earthworms and other soil macroorganisms. It improves soil water-holding capacity in the immediate area. It creates organic acids that increase micronutrient availability. And it adds organic carbon that builds long-term soil structure. No synthetic fertilizer on the market simultaneously does all 6. That is what should not be possible from a single banana peel. But honesty demands that we acknowledge the limitations. One banana peel is not going to transform an entire garden bed. The effect is real but localized, extending roughly 4 to 6 inches around the burial site. Fresh banana peels can temporarily cause nitrogen immobilization, meaning soil microbes may briefly take nitrogen from the surrounding soil to fuel their own growth during decomposition. Though this resolves within weeks and is negligible from a single peel, you should not bury banana peels directly against plant stems, because the active decomposition right at the stem base can invite rot or pest issues. A few inches away from the stem, out in the root zone, is ideal. Cutting or blending the peel into smaller pieces before burying will dramatically accelerate decomposition and could reduce the entire timeline by half. And the 9-day timeline assumes warm soil between 65 and 85 degrees, adequate moisture, and biologically active soil. In cold, dry, or heavily compacted soil, the process will take longer. Americans throw away approximately 3.5 million tons of banana peels per year. Most of those peels end up in landfills, where they decompose anaerobically and produce methane, a greenhouse gas far more potent than carbon dioxide. Every single peel buried in a garden is simultaneously free fertilizer, a soil biology booster, an act of carbon sequestration, and waste diverted from landfill. Start burying 1 banana peel per week, 4 inches deep, in a different spot each time around your plants. Over a single growing season, you will have systematically improved the soil biology across your entire garden bed, 1 burial at a time. The banana peel is not waste. It is a slow-release biological engine disguised as garbage. Stop throwing it away. Start burying it. The science says it works. The soil proves it works. And the plants that find it underground will show you exactly what should not be possible from something you almost put in the trash.